The universe expands in silence, carrying Earth through a cosmos where time itself might dream of flowing backward. In the quiet laboratories of theoretical physics, equations whisper of possibilities that challenge the very foundation of temporal flow, the assumption that yesterday precedes tomorrow with unwavering certainty. The second law of thermodynamics declares that entropy must increase. That order dissolves into chaos across cosmic ages. Yet beneath this proclamation lies a deeper mystery that quantum mechanics has begun to unveil. The arrow of time, so certain in our daily experience, becomes uncertain when examined through the lens of fundamental physics, where symmetry reigns supreme and causality bends like light around massive objects. In the subatomic realm, particles dance to rhythms that defy classical intuition. Quantum fluctuations emerge from the vacuum of space, creating pairs of virtual particles that exist for impossibly brief moments before annihilating back into nothingness. These ephemeral entities carry no preference for temporal direction. They appear equally comfortable moving forward or backward through time, as if the arrow of time were merely a macroscopic illusion, a statistical artifact of scale and perspective. The quantum vacuum seethes with activity, pairs materializing and vanishing in time frames so brief that uncertainty principles permit their temporary existence without violating conservation laws. The Earth spins through this quantum foam, its surface bathed in starlight that has travelled for eons to reach this moment. Yet even starlight carries secrets about time's nature. Photons experience no passage of time during their journey. From their perspective, emission and absorption occur simultaneously. They exist in an eternal present that encompasses all moments of their travel, suggesting that our experience of temporal flow might be nothing more than a consequence of our particular vantage point in the cosmic dance. Light connects all moments it touches into a single, timeless experience, binding distant stars to Earth's present in ways that transcend ordinary causality. Advanced wave solutions to Maxwell's equations propagate both forward and backward through time with equal mathematical validity. Only the boundary conditions of our universe seem to select which direction we experience as forward. The electromagnetic waves that warm Earth's surface could, in principle, originate from the future just as easily as from the past. Time itself appears symmetric at the fundamental level. With no inherent preference for any particular direction of flow, the equations that govern electromagnetic radiation contain both retarded and advanced solutions, suggesting that nature permits signals to travel backward through time just as readily as forward, if only we knew how to detect them. Scientists studying quantum foundations have discovered that certain experiments seem to suggest retrocausality, the ability of future measurements to influence past states. The delayed choice quantum eraser reveals how decisions made in the present can appear to determine the behavior of photons that have already completed their journey. These findings challenge our most basic assumptions about the relationship between cause and effect, suggesting that time's arrow might occasionally point toward yesterday without anyone noticing the difference. The quantum world operates according to rules that seem to mock our macroscopic experience of temporal sequence, where effects can precede their causes and the future can reach back to shape its own past. At the deepest level, the fundamental equations of physics exhibit a curious symmetry called CPT invariance. They remain unchanged when charge, parity, and time are all reversed simultaneously. This suggests that a universe running backward in time, with all charges reversed and all spatial coordinates inverted, would be indistinguishable from our forward-flowing cosmos. The laws of nature appear to be fundamentally indifferent to temporal direction, caring only for the mathematical relationships between events rather than their sequence in time. Even gravity, that most classical of forces, shows this temporal symmetry in Einstein's field equations, where matter curves space-time in patterns that work equally well when time flows backward. The cosmic microwave background radiation that bathes Earth carries within its subtle temperature fluctuations the imprint of quantum processes that occurred when the universe was barely 380,000 years old. Yet these same fluctuations might encode information about the universe's ultimate fate, If time's arrow can indeed point both ways, the boundary between past and future becomes blurred when examined through the mathematics of quantum cosmology, where the entire universe can be described as a single, vast quantum system evolving according to the Schrödinger equation, an equation that treats past and future with perfect symmetry. Ancient zircon crystals rest in silence within Earth's oldest rocks, their atomic lattices holding memories that stretch back 4 billion years to the planet's violent youth. These microscopic time capsules contain uranium atoms that decay with clockwork precision, their radioactive transformations marking the passage of eons with metronomic regularity. Yet within their crystalline structure lies a paradox that challenges our understanding of time's direction. Isotopic ratios that seem to whisper of futures that have not yet come to pass. Signatures that appear to violate the principle of causality itself. The crystal faces reflect starlight that began its journey when the universe was young, each photon carrying within itself the strange temporal symmetries that govern quantum mechanics at its deepest level. The lead isotopes locked within these ancient minerals tell stories that conventional physics struggles to explain. Some zircon samples contain lead-206 and lead-207 ratios that appear inconsistent with simple radioactive decay proceeding forward through time. The mathematics of nuclear physics permits both forward and backward decay processes. Though we observe only the forward direction in our macroscopic world, yet at the quantum level, the wave functions describing radioactive nuclei extend both into the past and future, creating probability clouds that encompass all possible moments of decay across vast expanses of time. The uranium-238 nucleus exists in a superposition of decayed and undecayed states until the moment of observation collapses the wave function. Selecting one particular history from among countless quantum possibilities, deep within Earth's mantle, the pressure reaches millions of times that at the surface, creating conditions where quantum effects might manifest on geological scales. Under such extreme compression, the very fabric of space-time becomes distorted, and the clear distinction between past and future begins to blur. Time dilation effects, normally associated with high velocities or intense gravitational fields, might create pockets where temporal flow becomes ambiguous, where the arrow of time wavers like heat shimmer above sun-baked stone. The immense gravitational field of Earth's core curves space-time sufficiently to create measurable time dilation, slowing the passage of time by microseconds compared to the surface, a tiny effect that accumulates over billions of years into significant temporal distortions. The beta decay processes that transform one element into another within these ancient crystals involve the weak nuclear force, one of nature's 4 fundamental interactions. This force exhibits a property called parity violation, meaning it can distinguish between left and right, yet it also participates in the deeper CPT symmetry that governs all of physics. When combined with charge conjugation and time reversal, the weak force exhibits perfect symmetry, suggesting that processes running backward in time should be just as valid as those proceeding forward. The radioactive transformations recorded in zircon crystals might represent not just the passage of time, but time's fundamental indifference to direction. Neutrinos produced by these decay processes carry away energy and momentum, disappearing into the Earth's interior where they interact so weakly with matter that they pass through the entire planet as if it were transparent. Quantum tunneling allows particles to pass through energy barriers that should be insurmountable according to classical physics. Within the atomic nuclei trapped in zircon lattices, protons and neutrons exist in quantum superposition states that span multiple possible configurations simultaneously. These quantum states extend across time as well as space, creating probability distributions that encompass past, present, and future in a single mathematical description. The tunneling process itself appears to occur instantaneously, as if the particle momentarily steps outside the normal flow of time to emerge on the other side of the barrier. Alpha particles escape from uranium nuclei through quantum tunneling, a process that classical physics predicts should take longer than the age of the universe, yet occurs routinely within these ancient crystals. The crystalline structure of zircon provides a nearly perfect preservation medium, protecting atomic arrangements from the chaos of geological processes for billions of years. Yet this preservation comes at a cost. The isolation necessary to maintain these ancient signatures also creates the conditions where quantum coherence might persist across geological timescales. Quantum systems can maintain their wave-like properties only when isolated from their environment, and the depths of Earth provide exactly such isolation. In these quiet, dark places, quantum effects that would normally be destroyed by decoherence might persist, creating pockets where time's arrow becomes uncertain. The silicon-oxygen tetrahedra that form zircon's backbone create a cage-like structure that shields the trapped uranium atoms from external influences, preserving their quantum states like insects in amber. Hafnium isotopes within these ancient crystals decay to lutetium through processes that span hundreds of billions of years, timescales that dwarf even geological ages. The extreme longevity of these nuclear transformations creates windows into deep time that stretch far beyond Earth's current age. Some scientists theorize that such long-lived processes might be influenced by the universe's expansion itself, with cosmic-scale effects reaching down to influence the behavior of individual atomic nuclei. The accelerating expansion of space-time could create temporal distortions that manifest as anomalous decay rates, signatures of a universe where future expansion influences past nuclear processes. The dark energy that drives cosmic acceleration might couple to nuclear processes through mechanisms not yet understood, creating subtle correlations between the fate of individual atoms and the destiny of the cosmos itself. Within the quantum vacuum that surrounds each atomic nucleus, virtual particle pairs constantly materialize and annihilate, creating a seething foam of quantum activity that extends throughout space and time. These virtual particles carry no respect for temporal direction. They emerge from future states just as readily as from past ones, creating a background of quantum noise that permeates all of space-time. The virtual photons that mediate electromagnetic forces between charged particles propagate both forward and backward through time, connecting past and future in a web of quantum correlation that spans the history of the universe. Tachyons dance through primordial soup, theoretical particles that move faster than light and carry information backward through the eons of Earth's earliest oceans. These hypothetical entities emerge from the mathematics of special relativity like phantoms, existing only in equations, yet possessing the remarkable property of travelling through time in reverse. When Einstein's theory permits velocities greater than light, it demands that such particles experience time flowing backward, their clocks run in reverse, their causal relationships invert, and their very existence challenges the fundamental assumptions about temporal order that govern our understanding of physical reality. In the ancient seas that covered Earth 4 billion years ago, amino acids drifted in warm tidal pools where lightning sparked and ultraviolet radiation cascaded through a thin atmosphere devoid of ozone. The primordial chemistry that would eventually give rise to life unfolded according to laws that permit both forward and backward time evolution. The Schrödinger equation that governs quantum systems is time-symmetric, treating past and future with perfect equivalence. If tachyons existed in these early oceans, they would have experienced the chemical evolution of life running in reverse, amino acids decomposing back into simpler molecules, complex reactions unfolding backward toward their initial states. The imaginary mass that tachyons must possess according to relativistic mechanics creates a strange relationship with energy and momentum. As these particles lose energy, they accelerate toward infinite velocity, while gaining energy slows them down, a complete reversal of normal particle behavior. In the quantum foam that underlies space-time, virtual tachyons might flicker into existence for infinitesimal moments, carrying information backward through time before vanishing into the vacuum from which they emerged. These ephemeral messengers from the future could influence the past in ways so subtle that they leave no detectable trace, yet collectively shape the evolution of complex systems across geological timescales. Quantum field theory describes tachyons as excitations of fields that have negative mass-squared values. Such fields are inherently unstable, rolling down their potential energy surfaces toward configurations of lower energy. This tachyonic instability drives phase transitions in the early universe, spontaneously breaking symmetries and creating the distinct forces and particles we observe today. The Higgs field itself underwent such a tachyonic instability shortly after the Big Bang, settling into its current vacuum state and endowing all other particles with mass. The echo of this primordial phase transition might still reverberate through space-time, creating subtle correlations between past and future that manifest as apparent backward causation. The superluminal group velocity of certain wave packets in dispersive media creates the illusion of faster-than-light propagation without actually transmitting information at superluminal speeds. Light pulses travelling through Earth's early atmosphere, thick with methane and ammonia, might have exhibited such anomalous dispersion. The leading edge of a wave packet could arrive before its peak, creating the appearance that information had travelled backward in time to announce its own arrival. These optical precursors carry no energy or information, yet they demonstrate how the boundary between cause and effect becomes blurred when examined closely through the lens of wave mechanics. Tachyonic fields coupled to ordinary matter could create closed time-like curves, paths through space-time that loop back to their own starting points in the past. Such curves would allow information to flow backward through time, creating the possibility of causal paradoxes where effects precede their causes. The energy density required to create macroscopic closed time-like curves exceeds anything achievable with known physics. Yet quantum fluctuations might spontaneously generate microscopic time loops that influence the behavior of elementary particles. These quantum-scale temporal shortcuts could allow future states to influence past measurements in ways that remain undetectable at the macroscopic level. The Wheeler-DeWitt equation that describes the quantum state of the entire universe contains no time parameter. It treats the cosmos as a single, timeless quantum system where all moments exist simultaneously. In this block universe picture, tachyons would not truly travel backward through time, but would instead connect spatially separated events in a four-dimensional space-time manifold. The appearance of backward time travel would emerge from our limited perspective as three-dimensional beings moving through the fourth dimension, unable to perceive the full geometry of space-time from our embedded vantage point. Feynman's Stueckelberg interpretation of antimatter describes antiparticles as ordinary particles moving backward through time. A positron travelling from past to future is mathematically equivalent to an electron travelling from future to past. This temporal symmetry suggests that all particle interactions are fundamentally reversible, with the arrow of time emerging only as a statistical preference in macroscopic systems. If tachyons exist, they might represent the temporal mirror image of ordinary particles, propagating backward through the four-dimensional fabric of space-time like ripples moving upstream against the current of cosmic expansion. The vacuum expectation value of tachyonic fields necessarily equals zero in the ground state, preventing the existence of stable tachyonic matter in our universe. Yet quantum fluctuations can create temporary violations of this constraint, allowing virtual tachyons to exist for brief moments before disappearing back into the vacuum. These virtual particles contribute to the quantum corrections that modify the behavior of ordinary matter, creating subtle effects that accumulate over cosmic timescales into observable consequences. The primordial soup that gave birth to life on Earth might have been subtly influenced by such virtual tachyonic processes, with future evolutionary outcomes reaching backward to guide the initial conditions of biochemical evolution. The second law dreams of reversal in the quiet spaces between atomic collisions, where entropy increases with relentless inevitability, yet harbours secret possibilities for temporal inversion. Ludwig Boltzmann's statistical interpretation reveals that the arrow of time emerges not from fundamental physics, but from the overwhelming probability that systems evolve towards states of greater disorder. Yet probability is not certainty, and the mathematics that govern molecular motion permit fluctuations so rare and brief that entropy might momentarily decrease. Time's arrow might waver, and the inexorable march toward thermodynamic equilibrium might stumble backward for infinitesimal moments before resuming its forward trajectory. In the primordial atmosphere of early Earth, methane and hydrogen molecules collided in endless Brownian dance, their kinetic energies redistributing according to Maxwell-Boltzmann statistics. Each collision conserved energy and momentum with perfect precision. Yet collectively, these interactions drove the system toward maximum entropy, a state where energy spreads evenly throughout all available degrees of freedom. The microscopic laws governing these collisions exhibit perfect time reversal symmetry, each interaction appearing identical whether viewed forward or backward through time. Only the statistical tendency for isolated systems to explore increasingly probable macroscopic states creates the appearance of temporal directionality. Poincare recurrence theorem proves that any finite system will eventually return arbitrarily close to its initial configuration, given sufficient time. The early Earth's atmosphere, containing a finite number of molecules within a bounded volume, must therefore experience episodes where entropy decreases and the system spontaneously organizes itself into more ordered states. These recurrence events occur on timescales so vast they exceed the age of the universe by factors beyond imagination, yet they represent genuine reversals of the thermodynamic arrow of time. In these fleeting moments of cosmic recurrence, the primordial atmosphere would recreate its initial conditions with startling precision, as if time itself were running backward. The H-theorem, derived by Boltzmann, demonstrates that entropy increases monotonically in isolated systems, yet this increase depends critically on the assumption of molecular chaos, that particle velocities remain uncorrelated over time. When correlations develop between particle motions, the H-theorem no longer applies, and entropy can decrease without violating any fundamental physical law. Quantum entanglement creates precisely such correlations, linking the properties of distant particles in ways that transcend classical description. Entangled systems can exhibit apparent violations of the second law, with entropy flowing from cold to hot regions through purely quantum mechanical processes. Loschmidt's paradox highlights the tension between time-symmetric microscopic laws and time-asymmetric macroscopic behavior. Ernst Loschmidt observed that the fundamental equations of motion remain unchanged when time is reversed. Yet macroscopic systems exhibit clear temporal directionality. The resolution lies in the choice of initial conditions. We observe systems that began in ordered states and evolved toward disorder. But the same laws would permit the reverse evolution if we could arrange appropriate initial conditions. The smooth, homogeneous early universe represents exactly such a special initial state, one so improbable that its existence suggests deeper principles governing the temporal structure of reality. Maxwell's demon, the hypothetical entity that could sort fast and slow molecules to create temperature differences without expending work, illustrates the intimate connection between information and thermodynamics. Modern information theory reveals that the demon must erase information to reset its memory, generating entropy that exactly compensates for any apparent violation of the second law. This connection suggests that information processing might provide a fundamental arrow of time, independent of thermodynamic considerations. Quantum computers that process information coherently might experience different temporal relationships than classical systems, with quantum algorithms potentially exhibiting retroactive influences on their initial states. The fluctuation theorem quantifies the probability of observing entropy-decreasing fluctuations in small systems over short time intervals. For microscopic systems monitored over brief periods, significant violations of the second law become not just possible but predictable. Living cells exploit such fluctuations to drive biochemical processes that appear to violate thermodynamic principles, concentrating molecules against concentration gradients and creating order from disorder through mechanisms that remain incompletely understood. These biological systems might represent natural examples of entropy-decreasing processes that operate through subtle quantum mechanical effects. Jarzynski equality relates the free energy difference between equilibrium states to the work performed during non-equilibrium processes. This remarkable theorem applies even when the second law appears to be violated, providing a deeper statistical foundation for thermodynamics that encompasses both forward and backward temporal evolution. The equality holds regardless of how quickly or slowly the process occurs, suggesting that thermodynamic relationships transcend the ordinary flow of time. Systems driven far from equilibrium might access temporal pathways unavailable to their equilibrium counterparts, following trajectories through phase space that loop backward through time before returning to forward temporal evolution. Brownian motion exhibits time reversal symmetry at the microscopic level, with individual particle trajectories appearing identical when viewed forward or backward through time. The symmetry emerges only when we consider the statistical properties of entire ensembles of particles. Time-reversed Brownian motion would appear as normal Brownian motion to any observer, indistinguishable from forward time evolution. This suggests that temporal directionality might be purely a matter of statistical perspective, with individual particles remaining agnostic about time's direction, while collective behavior creates the illusion of temporal flow. Quantum thermodynamics reveals that the second law must be modified when quantum effects become important. Quantum coherence and entanglement can drive thermodynamic processes that violate classical expectations, creating quantum heat engines that operate with efficiencies exceeding classical limits. These quantum effects might become significant in biological systems, where coherence can persist for surprisingly long times despite warm, noisy environments. Life itself might represent a quantum thermodynamic phenomenon that exploits temporal correlations, extending both forward and backward through time. Black holes digest time itself in the depths of space, where gravity grows so strong that the familiar flow of temporal sequence breaks down into something strange and unknowable. Near the event horizon of these cosmic devourers, time dilation stretches moments into eternities, while tidal forces tear apart the very fabric of causality. Stephen Hawking's calculation reveals that black holes emit radiation through quantum processes at their boundaries, a thermal glow that carries information outward from regions where time has ceased to flow in any conventional sense. This Hawking radiation emerges from the quantum vacuum itself, materializing from the marriage of general relativity and quantum field theory in ways that challenge our understanding of temporal order. The information paradox that surrounds black hole evaporation suggests that quantum information might flow backward through time to escape the gravitational prison. When a black hole forms from collapsing matter, that matter's quantum information appears to vanish behind the event horizon, yet conservation laws demand that information cannot be destroyed. As the black hole slowly evaporates through Hawking radiation, this information must somehow return to the outside universe. Recent theories propose that the information emerges encoded in subtle correlations within the outgoing radiation, correlations that reach backwards through time to connect the evaporation process with the original matter that formed the black hole billions of years earlier. The holographic principle suggests that all information contained within a volume of space can be encoded on its two-dimensional boundary. For black holes, this means that everything that falls past the event horizon remains encoded on the black hole's surface, existing simultaneously inside and outside the gravitational well. Time flows differently at different points on this holographic boundary, creating a complex temporal landscape where past and future intermingle in ways that defy simple description. An observer falling into the black hole experiences smooth passage through the event horizon, while external observers see the same fall frozen at the boundary for eternity. Quantum entanglement between particles inside and outside the event horizon creates correlations that transcend the classical notion of spatial separation. When one member of an entangled pair falls into a black hole while its partner remains outside, their quantum states remain correlated despite being separated by the event horizon. Measurements performed on the external particle instantaneously affect the state of its partner inside the black hole, creating a form of communication that appears to violate the principle that nothing can escape from inside the event horizon. This quantum correlation might provide a mechanism for information to flow backward through time from the black hole's interior to its exterior. The firewall paradox emerges from the tension between general relativity and quantum mechanics at the black hole boundary. If information is preserved during black hole evaporation, then the smooth space-time predicted by general relativity must give way to a wall of high-energy particles at the event horizon. This firewall would destroy any matter attempting to cross the boundary, yet it appears only when viewed from certain quantum mechanical perspectives. The resolution might require abandoning either the equivalence principle of general relativity or the unitarity of quantum mechanics, fundamental pillars of modern physics that seem to conflict near black hole horizons. Closed time-like curves can form in the ergosphere surrounding rotating black holes, regions where space-time itself is dragged along by the black hole's rotation. Within these curves, an observer could theoretically travel backward through time to encounter their own past. The exotic matter required to stabilize such curves against collapse might be provided by quantum field fluctuations enhanced by the black hole's gravitational field. Virtual particles that would normally annihilate within the vacuum might be separated by tidal forces, with one member falling into the black hole while its partner escapes to infinity, effectively borrowing energy from the black hole's rotation to create stable closed time-like curves. The AD-CFT correspondence establishes a mathematical relationship between gravity in higher dimensional anti-de Sitter space and quantum field theory on its lower dimensional boundary. This holographic duality suggests that black holes in the bulk spacetime correspond to thermal states in the boundary theory, with Hawking radiation representing thermal fluctuations in the dual quantum system. Time evolution in the gravitational theory corresponds to time evolution in the boundary field theory, yet the mapping between these temporal flows is highly non-trivial. Events that appear to occur at different times in the bulk might be simultaneous on the boundary, and vice versa. Quantum error correction codes provide a framework for understanding how information might be preserved and retrieved from black hole interiors, just as classical error correction allows recovery of damaged information by using redundancy. Quantum error correction might allow the reconstruction of information that has fallen into a black hole, using only the correlations present in the Hawking radiation. The black hole interior would represent the damaged portion of a larger quantum system, while the exterior and the outgoing radiation contain sufficient information to reconstruct the complete quantum state through appropriate decoding procedures. The page time marks the moment when a black hole has evaporated exactly half of its initial mass, a critical transition point where the character of Hawking radiation fundamentally changes. Before the page time, the radiation appears thermal and uncorrelated with the black hole's internal degrees of freedom. After the page time, the radiation becomes increasingly correlated with the black hole's interior, eventually carrying away all the information that originally fell in. This transition suggests that information might remain trapped near the event horizon for extended periods before suddenly beginning its escape, as if the black hole's memory were slowly returning from the depths of gravitational time dilation. Planck-scale physics near black hole horizons might reveal the granular structure of space-time itself, where the smooth continuum of general relativity gives way to a discrete quantum geometry. At these scales, the distinction between space and time becomes meaningless, with temporal relationships emerging only as statistical properties of more fundamental discrete structures. Black holes might represent regions where this underlying discreteness becomes manifest, creating temporal paradoxes and information puzzles that reflect the limitations of our continuous space-time description rather than genuine physical impossibilities. Quantum foam bubbles through bedrock at distances so small that space and time lose their meaning, dissolving into a seething ocean of uncertainty where the smooth continuum of space-time gives way to violent fluctuations that create and destroy virtual geometries with each tick of the Planck clock. At scales of 10 circumflex 35 meters and 10 circumflex 43 seconds, the familiar coordinates that locate events in space and time become meaningless approximations, rough averages over quantum processes that churn the very fabric of reality into configurations that defy classical description. The continental plates that drift across Earth's surface float above this quantum turbulence, their solid reality emerging from statistical regularities in the underlying foam. John Wheeler envisioned space-time at the Planck scale as a dynamic entity, constantly creating and annihilating microscopic wormholes that connect distant regions of the universe through quantum tunneling. These ephemeral bridges appear and vanish in time frames so brief that the uncertainty principle permits their temporary violation of energy conservation, borrowing vast amounts of energy from the vacuum before repaying the debt with interest. The topology of space-time becomes fluid at these scales, with holes opening and closing, bridges forming and dissolving, creating a multiply-connected manifold where the shortest path between 2 points might lead backward through time. Virtual black holes populate the quantum foam, microscopic gravitational collapse events that form and evaporate within single Planck intervals. These quantum black holes possess no classical event horizons, yet they inherit the strange temporal properties of their macroscopic cousins. Information that falls into a virtual black hole must emerge before the whole evaporates, creating closed causal loops where effects precede their causes by intervals shorter than the Planck time. The rock beneath our feet exists in superposition over all possible configurations of these virtual black holes, with its apparent solidity emerging only when averaged over countless quantum fluctuations. The principle of general covariance demands that the laws of physics remain the same regardless of the coordinate system used to describe them. Yet this principle becomes problematic when coordinates themselves fluctuate quantum mechanically. At the Planck scale, the very notion of a coordinate system breaks down as space-time geometry fluctuates too rapidly for any meaningful measurement of position or time. Events that appear simultaneous in one quantum frame might occur in reverse temporal order in another, with no objective way to determine which ordering is correct. The arrow of time emerges only as a statistical preference when many quantum geometries are averaged together. Causal sets represent one approach to quantum gravity that replaces continuous space-time with discrete networks of causally related events. In this framework, the fundamental structure of reality consists of partially ordered sets where some events precede others, while many pairs remain causally unrelated. Time emerges as the number of causal links in a chain connecting two events, while space emerges from the volume of causal diamonds, regions containing all events that can influence and be influenced by a given pair of events. The apparent smoothness of space-time at macroscopic scales results from coarse graining over enormous numbers of discrete causal relations. Loop quantum gravity describes space-time as a network of quantized geometric relationships, where area and volume come in discrete packets determined by the Planck scale. The spin networks that encode these geometric relationships evolve through discrete time steps, with each evolution representing a fundamental tick of a cosmic clock that operates below the threshold of any possible measurement. Time itself becomes granular, composed of indivisible moments separated by Planck intervals during which the usual notion of temporal sequence loses meaning. Between these moments, the universe exists in superposition over all possible geometric configurations. The Wheeler-DeWitt equation attempts to describe the quantum state of the entire universe, treating space-time geometry as a dynamical variable subject to quantum uncertainty. This equation contains no external time parameter, suggesting that time is not fundamental but emerges from the correlations between different geometric configurations. The universe as a whole exists in a timeless state, with the appearance of temporal evolution arising only from the perspective of observers embedded within particular geometric configurations. The quantum foam represents the fundamental timeless state from which our experience of flowing time crystallizes through the process of decoherence. Planck-scale wormholes might connect not only distant regions of space but also distant moments in time, creating a web of temporal connections that spans the history of the universe. Information could flow through these microscopic time tunnels, carrying influences from future events back to the past in ways that remain undetectable at macroscopic scales. The quantum foam becomes a communication network that connects all moments in cosmic history, with causality emerging only as a statistical property of the accumulated influences flowing through countless quantum wormholes. The holographic principle suggests that the quantum foam might be an illusion, a three-dimensional projection of information encoded on a two-dimensional surface. In this view, the apparent churning of space-time at the Planck scale reflects the fundamental processing of quantum information on a distant holographic screen. Time itself might be holographic, emerging from information processing operations that occur outside the space-time they appear to generate. The quantum foam would then represent the interior view of a cosmic computation that creates the experience of temporal flow through purely information-theoretic processes. Entanglement entropy provides a measure of the quantum correlations that bind different regions of space-time together through the quantum foam. When the vacuum is divided into spatial regions, the resulting entanglement between these regions follows a precise mathematical relationship to the area of their boundary surfaces. This area. Law for entanglement entropy suggests that space-time itself might be constructed from entangled quantum degrees of freedom, with the quantum foam representing the microscopic structure of these entanglement networks. Time evolution corresponds to the processing of quantum information through these entanglement networks, with temporal asymmetries arising from the initial conditions of the quantum entanglement pattern. Retrocausality sleeps in stone, hidden within the sedimentary layers where delayed choice experiments reveal how quantum measurements today might determine the state of particles billions of years ago. The limestone beneath ancient seabeds holds within its crystalline structure the fossilized remains of quantum decisions that were not made until eons after the particles had already chosen their paths. John Wheeler's delayed choice quantum eraser demonstrates that the act of measurement can retroactively determine whether a photon behaved as a wave or particle during its journey, even when that determination occurs long after the photon has completed its travel through space and time. The calcium carbonate that forms these limestone deposits precipitated from primordial oceans when photons from the young sun struck molecules of water and dissolved minerals. Each photon carried within itself a quantum superposition of all possible paths through the ancient atmosphere. Yet which path it actually took remained undetermined until the moment of measurement. Some of these measurements might not have occurred until billions of years later, when conscious observers developed the technology to perform delayed choice experiments that retroactively collapsed the wave functions of photons that had long since been absorbed into the growing limestone formations. Quantum interference patterns recorded in the mineral structure of ancient rocks might represent evidence of measurement choices that have not yet been made. The crystalline arrangements of atoms within these formations could preserve the quantum coherence of electromagnetic radiation from cosmic sources, maintaining interference patterns that depend on future measurement decisions. When astronomers eventually observed distant quasars through interferometric telescopes, their choice of measurement basis might retroactively determine the quantum states of photons that reached Earth billions of years ago, influencing the formation of geological structures through processes that transcend ordinary causality. The which path information that determines whether quantum particles exhibit wave or particle behavior can be erased after the particles have already been detected, retroactively restoring their wave nature and recreating interference patterns that appeared to have been permanently destroyed. This quantum eraser effect suggests that information about particle paths can be stored in quantum systems for arbitrary periods before being erased or revealed through appropriate measurements. Ancient rocks might serve as natural quantum memory devices, preserving which path information about cosmic radiation for geological ages until future experiments erase this information and retroactively modify the quantum history of particle interactions. Bell's theorem demonstrates that quantum correlations between entangled particles cannot be explained by any theory based on local hidden variables, yet these correlations can appear to propagate instantaneously across arbitrary distances. When particles become entangled and then separated by cosmic distances, measurements performed on one particle instantly affect the quantum state of its partner, regardless of the spatial and temporal separation between them. Cosmic ray particles that became entangled in distant stellar explosions might remain correlated with their partners throughout their journey to Earth, creating the possibility for delayed choice experiments to influence events that occurred in distant galaxies millions of years ago. The quantum Zeno effect allows frequent measurements to freeze the evolution of quantum systems, preventing them from transitioning between different states through this act of observation itself. Conversely, the anti-Zeno effect can accelerate quantum transitions through carefully timed measurements. These effects suggest that the temporal evolution of quantum systems depends critically on when and how measurements are performed, with the measurement schedule determining the rate at which quantum processes unfold through time. Ancient quantum systems preserved in geological formations might have their evolution rates modified by contemporary measurement activities, creating retroactive influences that span geological ages. Quantum contextuality reveals that the properties of quantum particles depend not only on what is measured, but also on what else could have been measured in the same experimental context. The measurement context defines the quantum reality that emerges from the superposition of possibilities, with different contexts revealing different aspects of the underlying quantum state. Archaeological measurements performed on ancient artifacts might retroactively determine the quantum properties of the materials from which they were formed. With the choice of measurement context influencing the quantum history of atomic interactions that occurred during their creation, the delayed choice entanglement swapping protocol allows two particles that have never interacted to become entangled through measurements performed on other particles with which they were previously correlated. This technique can create entanglement between particles separated in time as well as space, with measurements performed in the present creating quantum correlations that extend backward to influence the past states of particles that participated in earlier interactions. Cosmic background radiation from the early universe might become retroactively entangled with contemporary measurements, creating temporal correlations that span the entire history of the cosmos. Retrocausal interpretations of quantum mechanics propose that quantum systems are influenced by both their past preparations and their future measurements, with the complete description of quantum reality requiring knowledge of both initial and final boundary conditions. In this view, the wave function represents not just the quantum state evolving forward from past preparations, but also the influence of future measurements propagating backward through time. The apparent randomness of quantum measurements emerges from our ignorance of future boundary conditions rather than from fundamental indeterminacy in the quantum evolution. Weak measurements allow the extraction of limited information about quantum systems without completely disturbing their quantum coherence, providing a window into the quantum realm that preserves many features of the wave function while revealing partial information about quantum properties. These measurements can be performed retroactively on quantum systems that have already completed their evolution, extracting information about intermediate stages of quantum processes through post-selection on final measurement outcomes. Ancient quantum signatures preserved in geological formations might be accessible through weak measurements that retroactively reveal information about quantum processes that occurred billions of years ago without disturbing the evidence of their occurrence. Wheeler's cosmic telephone calls yesterday through information paradoxes that suggest the universe might be a closed time-like curve, calling itself from the future to arrange its own past in an endless loop of self-creation and self-determination. John Wheeler's vision of a participatory universe proposes that conscious observation plays a fundamental role in bringing physical reality into existence, with measurements performed in the present retroactively determining the properties of quantum systems throughout cosmic history. The universe might be engaged in a cosmic conversation with itself, using observers as intermediaries to exchange information between different epochs, creating a temporal feedback loop where the future shapes the past that shapes the future in an unbroken cycle of mutual causation. The delayed choice experiments that Wheeler proposed reveal how measurement decisions can retroactively determine the paths that photons took through cosmic space millions or billions of years ago. When astronomers observe distant quasars through gravitational lensing systems, Their choice of measurement basis determines whether the lensed photons took one specific path around the intervening galaxy or travelled along both possible paths simultaneously in quantum superposition. This measurement choice occurs billions of years after the photons began their journey, yet it retroactively determines their quantum history throughout their entire cosmic voyage, suggesting that the present continuously reshapes the past through the accumulated effects of observation. The quantum measurement problem becomes even more puzzling when considered on cosmic scales, where the collapse of the wave function must somehow occur without any external classical system to perform the measurement. If the universe as a whole exists in quantum superposition until observed, then who or what serves as the cosmic observer that brings reality into definite existence? Wheeler's solution invokes a principle of cosmic self-measurement, where the universe observes itself through the emergence of conscious observers within its own quantum evolution. The cosmos becomes a vast quantum computer that processes information about its own state, with consciousness arising as the universe's method of measuring itself. Strange loops emerge from this cosmic self-measurement, where the universe's attempt to know itself creates the very knowledge that determines what there is to know. The observer and the observed become entangled in a relationship that transcends simple subject-object dualism, with each defining the other through their mutual interaction. Consciousness might represent the universe's attempt to achieve self-awareness, a cosmic process that began with the emergence of quantum measurement capabilities in complex physical systems and continues through the development of increasingly sophisticated observers capable of probing deeper mysteries of quantum reality. The bootstrap hypothesis suggests that the universe might be entirely self-consistent, with no external foundation or ultimate ground of being. Every aspect of physical reality depends on every other aspect through a web of mutual determination that forms a closed logical loop. The laws of physics, the constants of nature, and the initial conditions of cosmic evolution might all be determined by requirements of self-consistency rather than by external causes or fundamental principles. The universe calls itself into existence by requiring its own existence as a necessary condition for its own possibility. Quantum gravity theories often invoke the principle of background independence, which demands that the laws of physics should not depend on any fixed space-time background, but should instead determine the structure of space-time dynamically. This principle creates a temporal bootstrap where the laws of physics determine the structure of time, while simultaneously depending on temporal relationships for their own definition. Time itself becomes a derived concept that emerges from more fundamental timeless relationships. Yet these relationships can only be defined through concepts that presuppose the existence of temporal structure. The anthropic principle observes that the universe appears to be fine-tuned for the existence of observers, with physical constants and natural laws calibrated to permit the emergence of complex structures capable of consciousness and measurement. Some interpretations suggest that this fine-tuning results from observer selection effects, where only universes capable of producing observers can be observed to exist. This creates a cosmic selection principle where the universe's capacity to know itself determines which possible universes become actual, with consciousness serving as the cosmic selection mechanism that chooses reality from among quantum possibilities. Wheeler's it from bit hypothesis proposes that all physical entities derive their existence from information-theoretic relationships, rather than from any underlying material substance. Reality consists of answers to yes or no questions, with physical properties emerging from the accumulation of binary distinctions, rather than from the interactions of fundamental particles or fields. The universe becomes a vast information processing system that creates itself through the act of processing information about its own state, with quantum measurements serving as the elementary information processing operations that generate physical reality from pure information. The cosmic microwave background radiation carries information about the quantum state of the early universe, preserving evidence of quantum fluctuations that occurred when the cosmos was barely 380,000 years old. Yet this information becomes physically meaningful only when interpreted by observers who have evolved the capability to detect and decode these ancient signals. The early universe might have existed in quantum superposition over all possible configurations until contemporary observers developed the technology to measure the cosmic microwave background, retroactively collapsing the wave function of the entire early cosmos through delayed choice cosmological measurements. Self-reference appears throughout the foundations of mathematics, logic, and computation, suggesting that self-referential structures might be fundamental features of any sufficiently complex information processing system. The universe's attempt to understand itself necessarily involves self-referential processes where the cosmos becomes both the subject and object of its own investigation. Gödel's incompleteness theorems demonstrate that any formal system capable of describing itself must contain undecidable statements that can neither be proved nor disproved within the system, suggesting that the universe's self-knowledge might be fundamentally limited by logical constraints that arise from the very attempt to achieve complete self-understanding. CPT symmetry rocks in silence through the fundamental equations that govern all physical interactions, a mathematical theorem stating that the laws of nature remain unchanged when charged. Parities, and time are all reversed simultaneously across cosmic scales. This profound symmetry suggests that a universe running backward in time, with all electric charges flipped and all spatial coordinates inverted like a photographic negative, would be indistinguishable from our forward-flowing cosmos. The quarks and electrons that compose the granite bedrock beneath ancient mountain ranges obey interactions that show perfect indifference to temporal direction when viewed through the lens of CPT transformation, treating past and future as equivalent partners in the cosmic dance of matter and energy. The electromagnetic force that binds atoms together in crystalline matrices exhibits perfect CPT symmetry, with Maxwell's equations remaining unchanged under the combined transformation of charge conjugation, parity inversion, and time reversal. Photons propagating through the mineral structures of metamorphic rocks carry no intrinsic preference for temporal direction. They interact with matter through processes that appear identical whether time flows forward or backward. The same electromagnetic interactions that built these geological formations over millions of years would operate with identical efficiency if time were reversed, dismantling the structures with the same mathematical precision that originally assembled them from dissolved minerals in ancient seas. The weak nuclear force responsible for radioactive decay processes violates both charge conjugation and parity symmetry individually, yet it preserves the combined CPT symmetry with exquisite precision. Beta decay reactions that transform unstable isotopes within uranium-bearing rocks proceed through weak interactions that distinguish between left and right, between matter and antimatter, yet these violations compensate perfectly when combined with time reversal to preserve the overall CPT symmetry. The apparent asymmetry between matter and antimatter in our universe might reflect a subtle violation of CP symmetry that must be compensated by a corresponding violation of time reversal symmetry to preserve the fundamental CPT theorem. The strong nuclear force that binds quarks into protons and neutrons exhibits perfect invariance under all discrete symmetries, including individual time reversal. The quantum chromodynamics that describes strong interactions treats past and future with complete equanimity, permitting processes to run equally well in either temporal direction. The nuclear binding energies that hold atomic nuclei together in the iron and nickel that populate Earth's core depend on strong force interactions that would remain unchanged if the entire planet's history were played backward, with nuclear fusion reactions in stellar cores proceeding through time-reverse sequences that convert helium back to hydrogen with identical efficiency. Noether's theorem connects symmetries to conservation laws through the principle that every continuous symmetry of a physical system corresponds to a conserved quantity. The CPT symmetry of fundamental physics implies the existence of conserved quantities that remain constant under the combined transformation of charge, parity, and time. These conservation laws constrain the possible evolution of physical systems in ways that transcend ordinary temporal considerations. creating relationships between past and future states that must be satisfied regardless of the direction of temporal flow. The conservation of CPT conjugate quantum numbers creates hidden connections between time-reversed processes that operate across geological ages. Quantum field theory builds CPT symmetry into its mathematical foundations through the spin statistics theorem, which relates the symmetry properties of particles to their quantum statistical behavior. Fermions and bosons exhibit opposite statistical properties that ensure the overall CPT invariance of all quantum field interactions, with the exchange statistics of identical particles compensating for potential violations of individual symmetries. The Pauli exclusion principle that prevents electrons from occupying identical quantum states emerges from the fermionic statistics that preserve CPT symmetry, creating the electronic structure of atoms that underlies the chemical bonding in all geological formations. The PCT theorem proves that any quantum field theory that satisfies basic physical requirements must exhibit exact CPT symmetry, making this symmetry one of the most fundamental principles in physics. This theorem constrains the possible forms that physical laws can take, ruling out theories that would distinguish between time-forward and time-backward evolution when combined with appropriate charge and parity transformations. The universality of CPT symmetry suggests that time reversal invariance represents a fundamental feature of physical reality rather than an accidental property of particular interactions. Discrete symmetries differ from continuous symmetries in their relationship to space-time structure, with CPT transformations representing discrete inversions rather than continuous rotations or translations. These discrete operations cannot be connected to the identity transformation through any continuous path, creating topological obstructions that prevent certain symmetry violations from occurring. The discrete nature of CPT symmetry protects it from the spontaneous breaking mechanisms that can destroy continuous symmetries, ensuring that CPT invariance remains exact even when other symmetries are violated by phase transitions or quantum corrections. The experimental verification of CPT symmetry tests some of the most fundamental assumptions underlying our understanding of space-time and quantum mechanics. Precise measurements of particle masses, lifetimes, and magnetic moments reveal that CPT symmetry holds to extraordinary accuracy, with any violations constrained to levels far below current experimental sensitivity. These tests probe the basic structure of quantum field theory in curved space-time, verifying that the combination of special relativity and quantum mechanics produces a consistent framework for describing physical reality across all accessible energy scales. The cosmological implications of CPT symmetry suggest that the entire universe might exhibit time reversal invariance when appropriate charge and parity transformations are applied. A cosmos dominated by antimatter and running backward through time would follow identical physical laws and exhibit the same structural evolution as our matter-dominated, forward-flowing universe. The apparent temporal asymmetry of cosmic evolution might reflect initial conditions rather than fundamental physical asymmetries, with the low entropy state of the early universe providing the only genuine arrow of time in an otherwise temporally symmetric framework governed by CPT invariant natural laws. Negative energy flows upstream through the quantum vacuum between tectonic plates, creating regions where the Casimir effect generates energy densities below the 0-point level and potentially reverses time's flow in microscopic pockets scattered throughout Earth's crust. The space between parallel conducting surfaces experiences a reduction in vacuum energy as certain quantum field modes are excluded by the boundary conditions, creating regions of genuinely negative energy density that violate the classical energy conditions required for normal temporal evolution. These Casimir regions might serve as natural laboratories where exotic physics manifests on geological scales, with the enormous pressures deep within Earth's interior amplifying quantum effects until they influence macroscopic processes. The quantum vacuum seethes with virtual particle pairs that materialize and annihilate in accordance with the uncertainty principle, borrowing energy from nothingness for infinitesimal moments before repaying the cosmic debt with interest. Between closely spaced surfaces in crystalline materials, certain vacuum fluctuation modes cannot exist due to geometric constraints, reducing the zero-point energy below its free space value. This energy deficit creates regions of negative energy density that seem to violate thermodynamic principles. Yet these violations are permitted by quantum mechanics for limited durations and in carefully constrained configurations. The Alcubierre drive mechanism for faster-than-light travel requires exotic matter with negative energy density to contract space-time in front of a spacecraft while expanding it behind, creating a warp bubble that carries the vehicle at superluminal speeds without violating relativity. While macroscopic quantities of exotic matter remain beyond current technology, the Casimir effect demonstrates that negative energy densities occur naturally in quantum systems. Deep within Earth's core, where pressures exceed millions of atmospheres and temperatures approach those of stellar interiors, quantum effects that are negligible at the surface might be amplified into macroscopic phenomena capable of warping space-time itself. Traversable wormholes connecting distant regions of space-time require negative energy to keep their throats open against the tendency of gravity to collapse these cosmic shortcuts into black holes. The quantum inequality theorems place severe limits on the magnitude and duration of negative energy densities. Yet these constraints might be circumvented in systems where quantum coherence is maintained over extended periods. The extreme isolation of materials deep within planetary interiors might provide the stable conditions necessary for large-scale quantum coherence, creating natural wormhole mouths that connect different epochs in Earth's geological history through negative energy stabilization. The quantum interest conjecture proposes that any classical violation of energy conditions must be compensated by an overabundance of positive energy elsewhere, with the compensation exceeding the original violation through a kind of quantum compound interest. This principle would prevent the construction of time machines or perpetual motion devices using negative energy, yet it permits temporary violations that could influence causal structure on limited scales. Geological processes operating over millions of years might accumulate sufficient quantum interest to permit brief episodes of macroscopic causality violation, creating windows where effects precede their causes through negative energy mediation. Hawking radiation from primordial black holes that might have formed in the early universe carries negative energy inward, while positive energy escapes to infinity, creating a gradual evaporation process that depletes the black hole's mass over cosmic timescales. If microscopic black holes exist within Earth's interior, perhaps trapped during the planet's formation from primordial matter, their Hawking evaporation would create persistent sources of negative energy that accumulate over geological ages. These ancient black holes might serve as natural reservoirs of exotic matter, slowly releasing negative energy that influences the causal structure of surrounding geological formations. The dynamical Casimir effect occurs when the boundary conditions that create negative energy regions change with time, converting virtual photons from the quantum vacuum into real particles through the motion of conducting surfaces. Tectonic activity that alters the spacing between crystalline planes in metamorphic rocks might trigger dynamical Casimir processes that extract energy from the vacuum while creating regions of negative energy density. The grinding motion of continental plates against each other provides a natural mechanism for time-varying boundary conditions that could amplify quantum vacuum effects into detectable geological phenomena. Squeezed quantum states of electromagnetic fields can exhibit negative energy densities in certain spatial regions while maintaining positive total energy through quantum correlations that span large distances. The piezoelectric properties of quartz and other crystalline minerals might create natural squeezing mechanisms that concentrate negative energy into microscopic domains within the crystal lattice. These quantum-squeezed regions could serve as seeds for larger-scale exotic matter accumulation, with the negative energy growing through resonant interactions with seismic waves that propagate through the Earth's crust. The holographic principle suggests that negative energy densities in the bulk spacetime correspond to exotic quantum states on the holographic boundary that encodes the same information. If Earth's interior exhibits holographic structure, with three-dimensional geological processes encoded in two-dimensional boundary dynamics, then negative energy regions might represent holographic projections of unusual quantum states that exist only on the encoding surface. The apparent negative energy would then be an artifact of the holographic mapping, rather than a genuine violation of energy conditions in the fundamental theory. Quantum field theory in curved spacetime predicts that certain spacetime geometries can support global negative energy densities without violating local energy conditions, creating exotic matter distributions that remain invisible to local observers while influencing the global causal structure. The gravitational field generated by Earth's mass curves the surrounding spacetime sufficiently to permit such global exotic matter configurations, with negative energy densities distributed throughout the planet's interior in patterns that preserve local energy positivity, while enabling macroscopic violations of classical causality constraints through accumulated quantum effects that span geological timescales. The grandfather paradox fossilizes in deep sedimentary layers where closed time-like curves threading through Earth's mantle raise questions about causality that ancient rocks cannot answer. These hypothetical paths through space-time loop back to their own starting points in the past, creating the possibility for information or matter to influence its own causal history through mechanisms that challenge the fundamental ordering of cause and effect. The limestone formations that preserve the remains of ancient life might themselves be embedded in space-time geometries that permit travel to the past, with the fossils serving as unwitting witnesses to temporal paradoxes that play out across geological scales through processes that remain hidden from direct observation. The Novikov self-consistency principle proposes that the universe automatically arranges events to prevent grandfather-type paradoxes, ensuring that any attempt to alter the past will necessarily fail or will have been the very action that created the past one was attempting to change. Under this principle, closed time-like curves become self-consistent causal loops where effects help to create their own causes, with the universe exhibiting a kind of global self-organization that maintains logical consistency across all temporal relationships. The geological record might preserve evidence of such self-consistent loops, with certain fossil arrangements or mineral distributions reflecting the influence of future events that reach backward through time to shape their own origins. Quantum mechanics provides additional mechanisms for resolving temporal paradoxes through the principle of quantum consistency, which permits multiple histories to coexist in superposition until quantum decoherence selects specific outcomes. A time traveler attempting to prevent their own birth might create a quantum superposition of contradictory histories that resolves into a consistent outcome only when observed by external systems. The quantum states of particles trapped in ancient crystal lattices might preserve evidence of such quantum historical superpositions, with interference patterns between different possible pasts encoded in the atomic arrangements of minerals that form during periods of temporal instability. The many worlds interpretation suggests that temporal paradoxes are resolved by branching into parallel timelines, with each possible outcome of a paradoxical situation creating a separate branch of the universal wave function. Time travelers who attempt to change the past succeed only in creating alternate timelines where the desired changes occur, while their original timeline remains unchanged in a parallel branch of reality. Archaeological evidence might reveal traces of such timeline branching events, with certain geological formations exhibiting quantum superposition signatures that reflect the coexistence of multiple parallel histories within the same space-time region. Wormhole networks threading through Earth's interior could create complex causal relationships where information travels through multiple connected shortcuts to arrive at its destination before it departed from its origin. These networks might form naturally through quantum tunneling processes in the high-pressure environment of the deep mantle, creating microscopic passages that connect distant points in space and time through exotic matter configurations. The seismic waves that propagate through the Earth's interior might occasionally traverse these wormhole shortcuts, creating earthquake precursors that arrive before their generating events through purely gravitational mechanisms. The chronology protection conjecture, proposed by Stephen Hawking, suggests that the laws of physics prevent the formation of closed time-like curves through quantum effects that become infinitely strong as space-time approaches a paradoxical configuration. Virtual particle loops in quantum field theory generate divergent stress-energy tensors near chronology horizons, creating a quantum firewall that destroys any attempt to create a time machine before it can generate paradoxes. The extreme conditions in Earth's core might approach the thresholds where such chronology protection mechanisms activate, creating regions where the fabric of space-time itself resists paradoxical configurations. Causal diamonds represent the maximum region of space-time that can be influenced by or can influence a given event, forming four-dimensional volumes bounded by past and future light cones. When closed time-like curves exist, these causal diamonds can overlap with themselves, creating regions where events can be both causes and effects of themselves through temporal loops. The geological processes that shape Earth's surface operate within causal diamonds that span millions of years, potentially encompassing temporal loops where mountain-building episodes influence their own initiation through mechanisms involving closed time-like curves in the planet's interior. The billiard ball model of temporal paradoxes demonstrates how classical mechanics can accommodate closed time-like curves without generating logical contradictions, provided the initial conditions are chosen appropriately. A billiard ball travelling through a wormhole might collide with its younger self in such a way that the collision deflects the younger ball into the wormhole, creating a self-consistent causal loop. Similar self-consistent loops might operate in geological systems, with seismic events triggering their own causes through complex feedback mechanisms that involve temporal shortcuts created by exotic matter configurations in the deep Earth. Information paradoxes arise when closed time-like curves permit the transmission of information to the past without any identifiable source for that information. Knowledge that arises from the future through temporal loops appears to emerge from nowhere, violating the principle that information must have causal origins. Ancient texts or artifacts that contain knowledge beyond their historical context might represent evidence of such information paradoxes, with future discoveries reaching backward through time to influence past civilizations through mechanisms that operate below the threshold of direct detection. The quantum Zeno effect can stabilize quantum states against decay through frequent measurements, while the anti-Zeno effect can accelerate quantum processes through carefully timed observations. These measurement-dependent evolution rates suggest that the presence of observers might influence the stability of closed time-like curves, with conscious observation playing a role in determining whether temporal paradoxes resolve in self-consistent ways. The evolution of life on Earth might represent a cosmic observation process that stabilizes certain causal relationships while allowing others to fluctuate, creating an anthropic selection mechanism that favors timelines capable of supporting the emergence of conscious observers who can witness their own causal origins. Many worlds branch backwards through the quantum multiverse, where each measurement splits reality into parallel Earths. Some where time might flow in reverse directions through mechanisms that remain hidden within the branching structure of the universal wave function. Hugh Everett's interpretation of quantum mechanics proposes that all possible outcomes of quantum measurements occur simultaneously in parallel branches of reality, with decoherence selecting which branch we experience while leaving all other possibilities equally real in their own dimensional domains. The radioactive decay of uranium atoms in ancient granite formations might have created countless parallel Earths, each differing in the precise timing of individual nuclear transformations that occurred billions of years ago. The universal wave function encompasses all possible configurations of matter and energy throughout cosmic history, evolving according to the Schrödinger equation in a vast Hilbert space that contains every conceivable arrangement of particles and fields. Each quantum measurement causes this wave function to branch into multiple components, creating parallel timelines that diverge from the moment of measurement while remaining mathematically connected through quantum interference terms. The countless quantum measurements that have occurred throughout Earth's geological history have generated an enormous tree of parallel worlds, with our particular timeline representing just one branch among an inconceivably vast number of alternative histories. Quantum decoherence explains how the superposition of quantum states gives way to definite classical outcomes through interactions with environmental degrees of freedom that become entangled with the measured system. In the many worlds framework, decoherence does not actually collapse the wave function, but instead creates the illusion of collapse by destroying the coherence between different branches of the multiverse. Each geological formation on Earth exists simultaneously in countless parallel configurations, with decoherence ensuring that inhabitants of each branch observe only one specific arrangement of rocks and minerals while remaining unaware of the parallel versions that coexist in other branches. The preferred basis problem in many worlds theory concerns the question of which quantum states correspond to distinct branches of reality. Since the mathematical formalism provides no unique prescription for dividing the wave function into separate worlds, environmental decoherence provides a partial solution by selecting basis states that remain stable under interactions with the surrounding environment. Yet this selection process might operate differently in parallel branches where environmental conditions differ. Some branches of the multiverse might exhibit decoherence patterns that favour different basis states, potentially creating parallel Earths where quantum measurements yield systematically different outcomes than in our observed timeline. Quantum immortality represents a controversial implication of many worlds theory, suggesting that conscious observers can never experience their own death because their awareness continues in whatever branches of the multiverse permit their survival. Applied to cosmic scales, this principle might explain the apparent fine-tuning of physical constants that permits the existence of complex structures like planets and life forms. The anthropic selection effect operates across the multiverse to ensure that conscious observers find themselves in branches where the laws of physics permit their existence, even if such branches represent an infinitesimally small fraction of all possible worlds. The relative state formulation describes quantum measurements as creating correlations between observer and observed system, rather than as causing objective collapse of the wave function. Each branch of the multiverse corresponds to a different relative state of the universal quantum system, with observers in each branch experiencing a consistent reality that appears classical due to environmental decoherence. The geological history of Earth represents one such relative state, with the apparent objectivity of rock formations and fossil records emerging from the correlations between conscious observers and their environmental quantum degrees of freedom. Interference between parallel branches can occur when quantum coherence is maintained across branching events, creating subtle correlations between different timelines that might manifest as apparent violations of classical causality. These interbranch influences remain exponentially suppressed by decoherence in most circumstances. Yet certain special configurations might permit measurable interference effects between parallel worlds. Ancient quantum systems preserved in stable geological formations might retain sufficient coherence to exhibit interference between alternative histories, creating anomalous patterns in mineral distributions or isotopic ratios that reflect the influence of parallel branches. The Sleeping Beauty problem in probability theory illuminates the challenges of assigning consistent probabilities to events across multiple branches of the multiverse. When a quantum measurement creates multiple copies of an observer in different branches, each copy might reasonably claim to represent the real outcome of the measurement, creating paradoxes about the objective probabilities of quantum events. Geological processes that depend on quantum measurements might exhibit statistical patterns that reflect this branching structure, with certain rock formations preserving evidence of quantum splitting events that created multiple parallel versions of Earth's history. Quantum error correction provides mechanisms for preserving quantum information across multiple branches of the multiverse, allowing certain types of information to remain accessible even when individual branches become inaccessible due to decoherence. The multiverse itself might function as a vast quantum error-correcting code, with information about fundamental physical processes distributed across many parallel branches in ways that permit recovery of the complete quantum state through measurements performed on accessible portions of the multiverse. Ancient geological formations might serve as natural quantum memory devices that preserve error-corrected information about Earth's quantum history across multiple parallel timelines. The measure problem concerns the question of how to assign probabilities or weights to different branches of the multiverse. Since the mathematical formalism provides no canonical measure for comparing the importance or reality of parallel worlds, different choices of measure can lead to dramatically different predictions about the likelihood of observing various phenomena, creating fundamental ambiguities in the empirical content of many worlds theory. The apparent stability and consistency of geological processes across Earth's history might reflect selection effects related to the choice of measure, with the observers naturally finding themselves in branches where stable geological processes permit the accumulation of coherent historical records that can be interpreted through scientific investigation. Cosmic microwave background echoes tomorrow through ancient photons that carry patterns which might encode information from Earth's future states. Their wavelength stretched by cosmic expansion yet preserving quantum correlations that span the entire history of the universe from its birth to its ultimate fate. These relic photons last scattered from the primordial plasma when the cosmos was barely 380,000 years old, yet their quantum entanglement with the matter that released them creates connections that transcend ordinary spatial and temporal boundaries. The temperature fluctuations mapped across the celestial sphere might reflect not only the quantum seeds of cosmic structure, but also the influence of future boundary conditions that reach backward through time to shape the initial conditions from which all subsequent evolution unfolds. The cosmic microwave background represents the afterglow of the universe's transition from opacity to transparency. When electrons and protons first combined to form neutral hydrogen atoms and photons began to travel freely through space. Yet quantum field theory permits advanced solutions that propagate backward in time with equal validity to the retarded solutions that describe normal forward-time evolution. Some fraction of the cosmic microwave background might consist of advanced waves emanating from the future state of the universe, carrying information about cosmic destiny back to observers in the present who interpret these signals as echoes from the primordial past. Wheeler-DeWitt quantum cosmology treats the entire universe as a single quantum system described by a wave function that encompasses all possible cosmic histories simultaneously. In this framework, the cosmic microwave background represents a superposition of radiation patterns corresponding to different possible evolutions of the early universe, with the observed pattern emerging through decoherence processes that select specific histories from the quantum multiverse of cosmic possibilities. The apparent randomness of temperature fluctuations might reflect quantum interference between different cosmic histories rather than classical statistical variations in the primordial density field. The holographic principle applied to cosmology suggests that all information contained within any region of space can be encoded on its two-dimensional boundary surface. For the observable universe, this boundary corresponds to the cosmic microwave background surface of last scattering, which might encode not only information about the early universe but also holographic projections of information from the entire future evolution of cosmic structure. The temperature and polarization patterns observed in the cosmic microwave background could represent holographic shadows cast backward through time by galaxy formation, black hole evolution, and other cosmic processes that have not yet occurred. Quantum entanglement between cosmic microwave background photons and the baryonic matter from which they scattered creates correlations that persist across cosmic time despite the expansion of space. These entangled systems might serve as a cosmic quantum communication network, allowing information to flow between different epochs through mechanisms that transcend ordinary light speed limitations. Measurements performed on cosmic microwave background radiation in the present might instantaneously influence the quantum states of matter in distant galaxies through these preserved entanglement correlations, creating retroactive effects that propagate backward through cosmic history. The cosmic variance that limits precision measurements of cosmic microwave background statistics on large angular scales might reflect the influence of boundary conditions at the end of cosmic time that constrain the possible range of initial conditions. In quantum cosmological models, where the universe exhibits time-symmetric boundary conditions, the apparent statistical properties of primordial fluctuations emerge from the requirement that initial and final states be mutually consistent, the observed power spectrum of cosmic microwave background anisotropies could encode information about the ultimate fate of cosmic expansion, dark energy evolution, and the approach to thermal equilibrium in the far future. Inflation theory proposes that cosmic microwave background fluctuations originated from quantum vacuum fluctuations that were stretched to cosmic scales during an exponential expansion phase in the very early universe. Yet the quantum vacuum exhibits zero-point fluctuations that extend into both past and future light cones, creating the possibility that inflationary amplification might stretch future-directed vacuum fluctuations as well as past-directed ones. The cosmic microwave background might thus contain imprints of quantum processes that will occur in the future history of the universe, amplified by inflation and redshifted by cosmic expansion into the millimeter wavelength radiation observed today. The cosmic neutrino background consists of relic neutrinos that decoupled from thermal equilibrium when the universe was approximately 1 second old, creating a sea of ultra-low energy neutrinos that permeates all of space. These neutrinos interact so weakly with matter that they preserve information about the early universe with extraordinary fidelity. Yet their quantum mechanical wave functions extend across cosmic scales and might encode correlations with future neutrino states. Measurements of the cosmic neutrino background, when they become technologically feasible, might reveal temporal correlations that span the entire history of cosmic evolution from the first second after the Big Bang to the heat death of the universe. The integrated Sachs-Wolf effect creates correlations between cosmic microwave background temperature fluctuations and the large-scale structure of the universe through gravitational interactions between photons and evolving cosmic density fields. This effect allows cosmic microwave background measurements to probe the history of cosmic structure formation across billions of years of cosmic evolution. If closed time-like curves exist on cosmic scales, the integrated Sachs-Wolf effect might create correlations between cosmic microwave background fluctuations and future structure formation events, allowing observations of the early universe to encode information about cosmic evolution that has not yet occurred. The quantum measurement of cosmic microwave background polarization patterns might retroactively determine the quantum states of primordial gravitational waves that created these polarization signatures through their interaction with the cosmic plasma. B-mode polarization measurements that detect or constrain primordial gravitational waves represent delayed choice experiments performed on quantum gravitational fields that exist in superposition over all possible amplitudes and phases until the moment of observation. The act of measuring cosmic microwave background polarization might retroactively collapse the wave function of the entire early universe, selecting specific quantum histories of cosmic inflation from among the vast ensemble of possibilities permitted by quantum cosmology. Wormholes tunnel through eons in the theoretical architecture of space-time. Einstein-Rosen bridges that connect distant points in the four-dimensional continuum and offer shortcuts that might lead backward through geological ages. These hypothetical passages emerge naturally from the mathematics of general relativity, when matter configurations create sufficient curvature to fold space-time back upon itself, forming tubes that connect separate regions of the cosmic manifold through pathways that bypass ordinary spatial and temporal separation. The immense pressures and densities that exist deep within planetary cores might approach the exotic conditions necessary to stabilize such space-time shortcuts, creating natural wormhole mouths that thread through Earth's interior like cosmic subway tunnels connecting different epochs in geological time. The traversable wormholes first analyzed by Morris and Thorne require exotic matter with negative energy density to prevent gravitational collapse, threading their throats with quantum fields that violate the classical energy conditions through purely quantum mechanical effects. The Casimir energy that emerges between closely spaced conducting surfaces creates precisely such negative energy configurations, suggesting that crystalline structures within metamorphic rocks might naturally generate the exotic matter needed to stabilize microscopic wormholes. These quantum-scale passages could serve as conduits for information transfer between different temporal periods, allowing geological processes to exhibit apparent violations of causality through the accumulation of microscopic temporal shortcuts. The Roman configuration describes a specific type of traversable wormhole where one mouth is accelerated to relativistic speeds and then returned to its starting location, creating a time machine through the combination of gravitational time dilation and special relativistic effects. If natural wormholes exist within Earth's mantle, tidal forces from the Moon and gravitational interactions with other planetary bodies might create the accelerated motion necessary to generate temporal gradients across wormhole throats. The slow orbital evolution of the Earth-Moon system over geological time could gradually transform spatial wormholes into temporal shortcuts that connect different eras in planetary history. Quantum foam at the Planck scale might contain vast networks of microscopic wormholes that spontaneously appear and disappear through quantum fluctuations in space-time geometry. These virtual wormholes exist for such brief intervals that they normally have no macroscopic consequences, yet they might become stabilized under extreme conditions where quantum coherence is maintained over extended periods. The high-pressure environment deep within planetary interiors provides exactly the kind of isolation from environmental decoherence that could allow virtual wormholes to persist long enough to influence geological processes through accumulated quantum tunneling effects. The topology change that occurs when wormholes form or disappear represents a fundamental alteration in the connectivity of space-time that cannot be described through smooth geometric evolution. Such topological transitions require quantum gravitational effects that remain beyond current theoretical understanding, yet they might occur naturally in regions where space-time curvature approaches the Planck scale. Seismic discontinuities within Earth's interior, such as the boundary between the mantle and core, might reflect underlying topological changes in space-time structure where wormhole networks form and dissolve through quantum gravitational processes. Wormhole networks could create complex causal relationships where information travels through multiple connected passages to reach its destination through pathways that violate ordinary temporal ordering. A signal entering a wormhole mouth in the present might emerge from a connected mouth in the past, then travel through normal space-time to influence events that occurred before the signal was originally transmitted. The global positioning system relies on precise timing corrections that account for relativistic effects, yet unexplained timing anomalies might reflect the influence of natural wormhole networks that create temporal shortcuts for electromagnetic signals traveling through Earth's interior. The no-hair theorem for black holes states that these objects can be completely characterized by their mass, charge, and angular momentum, with all other information about their formation being lost beyond the event horizon. Wormholes represent a potential mechanism for information to escape from black hole interiors without violating the no-hair theorem, providing passages that connect the interior and exterior regions through space-time shortcuts that bypass the event horizon. If primordial black holes exist within Earth's core, their associated wormhole networks might create information channels that connect the present epoch with the early universe when these black holes originally formed. The ER=sin EPR conjecture proposes that quantum entanglement between particles corresponds to the existence of wormhole connections between their locations in space-time. This correspondence suggests that the quantum correlations that bind entangled systems together might have a geometric interpretation in terms of space-time connectivity through microscopic wormhole bridges. The vast networks of quantum entanglement that permeate all matter might correspond to equally vast networks of microscopic wormholes that create a hidden connectivity between apparently separated regions of space and time. Cosmic strings, one-dimensional topological defects that might have formed during phase transitions in the early universe, could serve as raw material for wormhole construction through mechanisms that involve exotic matter accumulation along string world sheets. If cosmic strings became trapped within forming planetary systems during the early solar system's evolution, they might continue to exist within planetary interiors where they could generate the exotic matter configurations necessary to create and stabilize traversable wormholes. The magnetic field anomalies observed in certain geological formations might reflect the influence of cosmic string segments that thread through Earth's crust. The grandfather paradox takes on new complexity when wormholes permit travel to the past. Since the time traveller might emerge from a wormhole mouth at a location far from their departure point, potentially in a different galaxy or cosmic epoch entirely, this spatial displacement could allow paradox resolution through mechanisms where attempts to change the past succeed only in influencing distant regions of the universe that have no causal connection to the time traveller's original location. Geological evidence of such temporal displacement might appear as isotopic anomalies or mineral formations that exhibit signatures characteristic of different cosmic environments or evolutionary epochs. Block universe crystallizes eternally in the four-dimensional space-time manifold, where all moments exist simultaneously, past and future forming a single, unchanging geological crystal that extends through time as mountains extend through space. Einstein's theory of relativity reveals that simultaneity depends on the observer's reference frame, with events that appear simultaneous to one observer occurring in sequence for another observer moving at different velocities. This relativity of simultaneity suggests that the distinction between past, present, and future represents a subjective illusion rather than an objective feature of reality, with all moments in cosmic history possessing equal ontological status in the eternal structure of the block universe. The world lines that trace the paths of particles through four-dimensional space-time form an immutable network of causal relationships that extends from the Big Bang to the heat death of the universe. Each atom in Earth's crust follows a predetermined trajectory through this temporal landscape, with its entire history from cosmic nuclear synthesis to eventual decay encoded in the geometric structure of space-time itself. The limestone formations that preserve ancient marine fossils represent cross-sections through this four-dimensional reality, revealing glimpses of the eternal patterns that connect all moments in Earth's geological evolution through the unchanging architecture of relativistic space-time. The relativity of simultaneity implies that there exists no universal present moment that divides past from future throughout the cosmos. Observers in different reference frames will disagree about which events are simultaneous, with their disagreement growing larger as the spatial separation between events increases. For events separated by galactic distances, observers moving at ordinary velocities will disagree about temporal ordering by millions of years, suggesting that the entire history of Earth's geological evolution might be occurring simultaneously from the perspective of appropriately chosen reference frames in distant galaxies. Minkowski's space-time provides the mathematical framework for understanding how space and time unite into a single four-dimensional continuum, where temporal relationships become geometric properties of the manifold structure. The interval between events in space-time remains invariant under Lorentz transformations, just as the distance between points in space remains unchanged under rotations of the coordinate system. This geometric interpretation suggests that the flow of time represents a coordinate-dependent phenomenon similar to the choice of spatial orientation, with no objective meaning independent of the observer's reference frame embedded within the space-time manifold. The eternal return hypothesized by some cosmological models proposes that the universe undergoes cyclical evolution, with each cosmic cycle repeating the exact same sequence of events through mechanisms involving quantum recurrence or cyclic cosmological dynamics. In such models, every moment in Earth's geological history occurs infinitely many times, with each recurrence identical to all others down to the quantum level. The block universe would then consist of infinitely many identical temporal slices stacked upon one another, creating a crystalline structure where time exhibits perfect periodic symmetry across cosmic scales. Closed time-like curves that loop back to their own starting points in the past create regions of space-time where the block universe exhibits non-trivial topology, with world lines that close upon themselves through mechanisms involving exotic matter or extreme gravitational fields. These temporal loops represent permanent features of the four-dimensional space-time geometry, existing eternally as fixed structures that connect different temporal regions through pathways that transcend ordinary causal ordering, the geological processes that shape planetary surfaces might occasionally traverse such closed time-like curves, creating fossil records that preserve evidence of self-consistent causal loops. The Wheeler-DeWitt equation that describes quantum cosmology treats time as an emergent property that arises from correlations between different components of the universal wave function, rather than as a fundamental parameter of the theory. In this timeless formulation of quantum gravity, the block universe represents the most probable configuration of the cosmic wave function, with the appearance of temporal flow emerging through decoherence processes that select specific correlations between matter and geometric degrees of freedom. The four-dimensional crystal of space-time events emerges from quantum interference patterns in the universal wave function. Causal set theory proposes that space-time consists of discrete networks of causally related events rather than continuous manifolds, with temporal relationships defined by the partial ordering of causal connections between discrete space-time points. The block universe becomes a vast network of nodes and links, with each geological event corresponding to a cluster of causally connected nodes in this discrete structure. The apparent smoothness of space-time at macroscopic scales emerges through coarse graining over enormous numbers of discrete causal relations, just as the apparent continuity of matter emerges from the statistical behavior of discrete atoms. The holographic principle applied to cosmology suggests that the entire block universe might be encoded as information on a two-dimensional surface, with the four-dimensional space-time manifold representing a holographic projection of more fundamental degrees of freedom that exist on the cosmic boundary. In this view, the geological history of Earth represents a three-dimensional shadow cast by information processing operations that occur on a distant holographic screen, with temporal relationships emerging from the computational structure of the boundary theory, rather than from genuine temporal evolution in the bulk space-time. Many worlds quantum mechanics treats the block universe as one branch of an enormous quantum multiverse, where all possible space-time configurations exist simultaneously in different components of the universal wave function. Each possible geological history of Earth corresponds to a different branch of this quantum multiverse, with our observed timeline representing just one cross-section through a vast ensemble of alternative block universes. The apparent uniqueness of our geological record emerges through environmental decoherence that selects specific branches from the quantum superposition, while rendering all other possibilities inaccessible to direct observation. Yet these alternative timelines remain equally real in the broader structure of the quantum multiverse. Advanced waves travel home through the electromagnetic field equations that permit retarded and advanced solutions with equal mathematical validity, carrying signals from Earth's destiny backward through the geological ages. Maxwell's equations contain no fundamental asymmetry between past and future, allowing electromagnetic radiation to propagate both forward and backward through time, depending only on the boundary conditions imposed at the temporal limits of the system under consideration. The radio waves that modern civilizations broadcast into space represent only half of the complete electromagnetic solution. Their time-reversed counterparts propagate backward from future receiving events, converging on transmission points from the direction of tomorrow rather than emanating outward toward yesterday. The Wheeler-Feynman absorber theory proposes that electromagnetic radiation requires both emitters and absorbers to achieve physical reality, with advanced waves from future absorption events traveling backward to meet retarded waves from past emission events at the moment of transmission. This symmetric formulation eliminates the need for electromagnetic fields to exist independently of their sources, instead treating radiation as a time-symmetric interaction between charged particles separated in space-time. The cosmic background radiation that bathes Earth might consist partly of advanced waves emanating from the ultimate fate of the universe, carrying information about cosmic destiny backward through billions of years to influence contemporary measurements of the primordial cosmos. The lightning strikes that illuminate Earth's atmosphere create electromagnetic pulses that propagate outward at the speed of light. Yet the complete solution to Maxwell's equations includes advanced wave components that arrive at the lightning channel from the future moments when these electromagnetic pulses are absorbed by distant matter. These advanced waves remain undetectable because they are exactly cancelled by interference with the retarded waves that propagate forward from the same emission event. Yet their presence ensures that the total electromagnetic field configuration satisfies the boundary conditions imposed by future absorption events throughout the cosmos. Quantum electrodynamics describes photon emission and absorption through interactions between matter and the quantized electromagnetic field. Yet these interactions exhibit perfect time reversal symmetry when CPT invariance is taken into account. A photon travelling from past to future is mathematically identical to an antiphoton travelling from future to past, suggesting that electromagnetic radiation might consist of equal mixtures of forward and backward propagating components that interfere constructively in the forward time direction while cancelling in the backward direction. This interference pattern creates the illusion of purely retarded radiation while preserving the underlying time-symmetric structure of electromagnetic interactions. The Planck satellite's precise measurements of cosmic microwave background temperature fluctuations might contain subtle signatures of advanced wave components that originated from the far future absorption of this radiation by black holes, dark matter, or exotic cosmic structures that have not yet formed. These future absorption events could influence the apparent statistical properties of primordial fluctuations through time-symmetric electromagnetic interactions that operate below the threshold of current measurement precision. The cosmic microwave background represents a cosmic laboratory where advanced wave effects might accumulate over billions of years into detectable deviations from purely retarded wave predictions. Coherent electromagnetic radiation exhibits phase relationships that can be maintained over vast distances and extended time periods, creating the possibility for advanced wave effects to manifest in systems where electromagnetic coherence spans geological timescales. The natural laser action that occurs in certain astronomical masers might involve advanced wave components that help to maintain coherence through time-symmetric feedback mechanisms connecting future and past electromagnetic field configurations. These cosmic masers could serve as natural detectors of advanced wave phenomena, exhibiting temporal correlations that transcend ordinary light-speed causality through pure electromagnetic processes. The transactional interpretation of quantum mechanics treats quantum interactions as time-symmetric transactions between offer waves propagating forward in time and confirmation waves propagating backward from future measurement events. In this framework, the collapse of the wave function represents the formation of a time-symmetric transaction that connects past preparations with future measurements through advanced wave components that remain invisible in conventional formulations of quantum theory. Archaeological artifacts that contain quantum information might preserve evidence of such transactions, with their quantum states reflecting the influence of future measurement events that have not yet occurred. Electromagnetic radiation in conducting media exhibits skin depth effects that concentrate alternating currents near the surfaces of conductors, yet the complete electromagnetic solution includes advanced wave components that originate from future current distributions and propagate backward to influence present electromagnetic field configurations. The Earth's magnetosphere interacts with solar wind through electromagnetic processes that might involve advanced wave components connecting future geomagnetic storms with their parsolar causes, creating feedback loops that span the solar terrestrial system through time-symmetric electromagnetic interactions. Cavity quantum electrodynamics studies the interaction between atoms and electromagnetic fields in confined geometries where boundary conditions play crucial roles in determining the allowed field configurations. These cavities might naturally select for advanced wave components that satisfy specific temporal boundary conditions, creating environments where future electromagnetic events influence past atomic transitions through mechanisms involving time-symmetric field configurations. Natural cavities within crystalline formations might serve as geological scale demonstrations of advanced wave effects, preserving electromagnetic signatures that reflect the influence of future cosmic events on past geological processes. The sum over history's formulation of quantum electrodynamics includes contributions from all possible electromagnetic field configurations, including those that involve advanced wave propagation between future and past events. These advanced contributions normally cancel when summed over all possible field histories, yet certain special configurations might exhibit constructive interference between advanced and retarded components that creates measurable deviations from conventional electromagnetic predictions. Ancient lightning strikes preserved in fulgurite formations might contain electromagnetic signatures that reflect the accumulated influence of advanced wave components over geological time periods, creating fossilized records of time-symmetric electromagnetic interactions. Quantum gravity dreams of reversal at the Planck scale where time itself becomes granular and uncertain, flickering between forward and backward directions like a cosmic strobe light operating at frequencies of 10 circumflex 43 cycles per second. The smooth flow of temporal experience dissolves into discrete quantum moments separated by intervals so brief that the uncertainty principle permits violations of energy conservation on scales where space-time geometry itself fluctuates wildly between different topological configurations. At these fundamental scales, the distinction between past and future loses meaning as quantum superposition encompasses all possible temporal ordering simultaneously, with the arrow of time emerging only as a statistical preference when countless quantum gravity fluctuations are averaged over macroscopic intervals. Loop quantum gravity discretizes spacetime into networks of quantized geometric relationships, where area and volume come in fundamental units, determined by the Planck length squared and cubed respectively. These spin networks evolve through discrete time steps called Planck intervals, each representing an irreducible quantum of temporal passage during which the basic geometric building blocks of space-time can change their connectivity and orientation. The evolution between successive Planck moments exhibits no preferred temporal direction, with forward and backward transitions appearing with equal probability in the fundamental quantum gravity dynamics that govern the microscopic structure of the space-time continuum. The Wheeler-DeWitt equation that attempts to describe the quantum state of the entire universe contains no time parameter, treating cosmic evolution as a sequence of correlations between different geometric configurations rather than as temporal development through an external time coordinate. In this timeless formulation, the universe exists in a superposition over all possible space-time geometries simultaneously, with the appearance of temporal flow emerging through entanglement between gravitational and matter degrees of freedom. The quantum state of space-time itself might fluctuate between configurations where time flows forward and others where it flows backward, with observers embedded within specific geometric branches experiencing only one temporal direction. Causal dynamical triangulation represents space-time as a network of four-dimensional simplexes that evolve through discrete time steps, with each simplex representing a fundamental quantum of space-time volume. The causal structure of this discrete space-time emerges through constraints that prevent time-like loops from forming at the fundamental level. Yet these constraints operate statistically rather than deterministically. Individual Planck scale regions might occasionally violate causal ordering, creating microscopic closed time-like curves that influence the global causal structure through accumulated quantum effects that span macroscopic space-time regions. The holographic principle applied to quantum gravity suggests that space-time emerges from entanglement patterns in quantum information processing systems that exist on lower dimensional boundary surfaces. Time itself might be an emergent property that arises from the computational structure of these boundary theories, with temporal asymmetries reflecting the information processing capabilities of the holographic encoding rather than fundamental properties of space-time geometry. The apparent smoothness of temporal flow would then represent a coarse-grained approximation to more fundamental discrete information processing operations that exhibit no intrinsic temporal directionality. String theory describes fundamental particles as vibrating loops of energy in higher dimensional spaces where the extra spatial dimensions are compactified on scales comparable to the Planck length. The vibrational modes of these strings include both forward and backward time-traveling components that contribute equally to particle interactions, with the observed temporal asymmetry emerging through spontaneous symmetry, breaking mechanisms that select specific vacuum configurations from among the vast ensemble of possibilities permitted by string dynamics. T-duality in string theory relates different string compactifications through transformations that can reverse the effective direction of time flow in the compactified dimensions. Asymptotic safety scenarios for quantum gravity propose that the theory becomes scale invariant at high energies, with all dimensionful coupling constants flowing to finite fixed points under the renormalization group. This scale invariance might extend to temporal relationships, creating regimes where the distinction between past and future becomes meaningless due to the absence of any natural timescale that could define temporal direction. The approach to the asymptotic safety fix point could create windows where quantum gravity effects permit apparent violations of causality through mechanisms involving the loss of temporal orientation in strongly coupled gravitational systems. The black hole information paradox suggests that quantum information cannot be destroyed even when matter falls past event horizons. Yet general relativity predicts that information becomes causally disconnected from external observers when it crosses into black hole interiors. Quantum gravity might resolve this paradox through mechanisms involving microscopic wormholes or other topological features that allow information to escape from black hole interiors by travelling backward through time before the formation of the event horizon. The Hawking radiation that emerges from black hole evaporation could carry encoded information about future black hole states back to past observers through quantum gravitational processes. The problem of time in quantum gravity reflects the difficulty of reconciling the general covariance of Einstein's theory with the fundamental role that time plays in quantum mechanical evolution. Different approaches to quantum gravity treat time in fundamentally different ways, with some theories eliminating time altogether, while others quantize temporal relationships along with spatial geometry. The resolution might require abandoning the notion that time has any fundamental significance, instead treating temporal relationships as emergent properties of more basic quantum gravitational degrees of freedom that operate according to timeless dynamical principles. Emergent gravity theories propose that gravitational interactions arise from entanglement properties of more fundamental quantum systems rather than from the curvature of space-time itself. In these approaches, space-time geometry emerges through collective behavior of quantum entanglement networks, with temporal relationships reflecting the information processing structure of these quantum systems rather than fundamental temporal coordinates. The arrow of time would then represent a macroscopic property that emerges from microscopic quantum information processing, with the possibility for temporal reversal in systems where quantum coherence can be maintained across macroscopic scales through exotic quantum error correction mechanisms. The universe remembers its end through cosmological models that suggest our expanding cosmos might be guided by its own final state. Quantum tunneling effects that connect the present moment with the ultimate destiny of all matter and energy. The omega point hypothesis proposes that the universe evolves toward a state of maximum information processing capacity, with the approach to this cosmic attractor influencing the entire history of cosmic evolution through teleological principles that operate across the vast scales of space and time. Dark energy, the mysterious force that drives cosmic acceleration, might represent the universe's response to its own future state, creating a cosmic feedback loop where the final configuration of matter and energy reaches backward through time to guide the expansion history that leads to its own realization. The anthropic principle observes that the fundamental constants of nature appear precisely tuned to permit the existence of complex structures capable of observation and thought, suggesting that the universe's capacity to know itself might play a role in determining the physical laws that govern cosmic evolution. This fine-tuning could result from a cosmic selection process where only universes capable of developing consciousness and intelligence achieve stable existence, with the requirement for eventual observation serving as a boundary condition that constrains the possible forms that physical reality can take. The emergence of life and intelligence on Earth might represent inevitable consequences of cosmic evolution towards self-awareness, rather than unlikely accidents in an indifferent universe. Wheeler's participatory universe proposes that conscious observation plays a fundamental role in bringing physical reality into definite existence through the process of quantum measurement. This principle might operate on cosmic scales, with the universe requiring observers to collapse its quantum wave function and select specific histories from the vast ensemble of quantum possibilities. The delayed choice experiments that demonstrate retrocausality in quantum systems could scale up to cosmic proportions, with contemporary astronomical observations retroactively determining the quantum state of the early universe through measurements that collapse primordial superposition states billions of years after the events they determine. The final anthropic principle suggests that once information processing capabilities emerge in the universe, they will continue to grow without limit, eventually encompassing all available matter and energy in a cosmic intelligence that persists until the ultimate fate of space-time itself. This cosmic mind would possess complete knowledge of the universe's history and complete control over its future evolution, creating the possibility for retroactive influences that guide the development of cosmic structure toward configurations that maximize information processing capacity. The formation of galaxies, stars, and planets might reflect the influence of this future cosmic intelligence reaching backward through time to create the conditions necessary for its own emergence. Quantum cosmology treats the entire universe as a single quantum system described by a wave function that encompasses all possible cosmic histories simultaneously. The boundary conditions that select specific branches from this quantum multiverse might include both initial conditions at the moment of cosmic creation and final conditions at the ultimate fate of the universe. These temporal boundary conditions would create a cosmic selection principle where only self-consistent histories that connect appropriate initial and final states achieve physical reality. The observed properties of our universe might reflect the requirements for consistency between cosmic beginning and cosmic end. The cosmological constant problem reveals a profound mystery in our understanding of dark energy, with quantum field theory predicting vacuum energy densities that exceed observations by more than 100 orders of magnitude. The resolution might involve anthropic selection effects where the observed value of the cosmological constant reflects the requirements for cosmic evolution to produce observers capable of measuring it. Only universes with cosmological constants in a narrow range can develop the complex structures necessary for consciousness, creating a selection effect that explains the apparent fine-tuning without requiring fundamental changes to our understanding of quantum field theory. Eternal inflation creates an infinite multiverse where all possible vacuum configurations are realized somewhere within the exponentially expanding cosmic ensemble. Most regions of this infinite cosmos exhibit cosmological constants and physical laws that prevent the formation of complex structures, yet observers can only emerge in the rare regions where conditions permit their existence. The anthropic selection that operates across this infinite multiverse might create apparent teleological effects, where cosmic evolution appears guided toward consciousness and intelligence. Even though these effects result from observer selection rather than genuine cosmic purpose, the holographic principle applied to cosmology suggests that the entire observable universe might be encoded as information on its two-dimensional boundary surface. This cosmic hologram might include information about both the past and future evolution of cosmic structure, with the present state representing a cross-section through a four-dimensional information structure that encompasses the complete cosmic history. The apparent temporal flow would then emerge from the information processing operations that decode this holographic cosmic database. With consciousness representing the universe's method of reading its own holographic memory, quantum error correction provides mechanisms for preserving information across multiple copies of quantum systems, allowing robust information storage even when individual copies become corrupted through decoherence or other quantum processes. The universe itself might function as a vast quantum error-correcting code, with information about cosmic purpose and final destiny distributed across many parallel quantum histories in ways that ensure robust transmission of teleological influences from future to past. The anthropic selection that favours universes capable of producing observers might represent one aspect of this cosmic error correction system. The mathematical universe hypothesis proposes that physical reality consists entirely of mathematical structures, with conscious observers representing information processing subsystems within these mathematical entities. In this framework, the universe's evolution toward consciousness and intelligence reflects the mathematical inevitability of self-referential structures that develop the capacity to model their own behavior. The apparent guidance of cosmic evolution toward observation and intelligence would then represent a fundamental property of mathematical existence, rather than a contingent feature of particular physical processes, with consciousness emerging wherever mathematical structures achieve sufficient complexity to support self-referential information processing that connects cosmic past with cosmic future. Time crystals vibrate in stillness through periodic structures that maintain their rhythm while the universe ages, repeating their patterns through discrete temporal intervals that resist the natural tendency toward thermodynamic equilibrium. These exotic phases of matter exhibit spontaneous breaking of temporal translation symmetry, creating systems that oscillate eternally without energy input through quantum mechanical effects that preserve coherent motion across arbitrary timespans. The first time crystals discovered in laboratory conditions consist of trapped ions that flip their quantum states in regular cycles, driven purely by the symmetry-breaking properties of their ground state configurations, demonstrating that temporal periodicity can emerge as a fundamental property of quantum systems, rather than requiring external driving forces. The Floquet time crystals that emerge in periodically driven quantum systems exhibit discrete time translation symmetry breaking, oscillating at frequencies that represent exact fractions of their driving frequency through many-body quantum interactions that resist thermalization. These systems absorb energy from their periodic drives, yet channel this energy into coherent, collective oscillations that persist indefinitely without approaching thermal equilibrium. The crystalline structures deep within Earth's mantle might support analogous time crystal phases, where periodic tidal forces from celestial bodies drive quantum many-body systems into non-equilibrium steady states that exhibit temporal crystalline order across geological timescales. The classification of time crystal phases reveals a rich taxonomy of temporal symmetry-breaking patterns that includes both discrete and continuous time crystals, with different symmetry-breaking mechanisms creating distinct classes of temporal order. Discrete time crystals break the discrete temporal symmetry of their periodic driving forces, while continuous time crystals spontaneously develop oscillatory behavior in systems with continuous temporal symmetry. The quantum field fluctuations that permeate the vacuum of space might support continuous time crystal phases, where spontaneous temporal symmetry breaking creates persistent oscillations in the quantum vacuum energy density that maintain their frequency across cosmic timescales. The many-body localization that protects time crystal phases from thermalization occurs when quantum systems become sufficiently disordered that they fail to reach thermal equilibrium even when subjected to strong interactions and external driving forces. In these localized phases, different regions of the system retain memory of their initial conditions indefinitely, creating persistent temporal correlations that resist the entropy increase demanded by the second law of thermodynamics. The complex mineral compositions found in metamorphic rocks might provide the disordered landscapes necessary to support many-body localized time crystal phases that preserve temporal order across geological ages. The prethermal time crystals that emerge in weakly interacting quantum systems exhibit temporal crystalline order for exponentially long periods before eventually thermalizing through slow, many-body processes that operate on timescales far exceeding any practical observation window. These systems demonstrate that thermal equilibrium represents an asymptotic limit rather than an inevitable destination. With many quantum systems capable of maintaining coherent temporal order for durations that exceed the age of the universe, the quantum coherence that persists in certain biological systems might represent natural examples of pre-thermal time crystal behavior where temporal order emerges from the interplay between quantum mechanics and classical environmental fluctuations. The space-time crystals that break both spatial and temporal translation symmetries simultaneously create four-dimensional crystalline structures that repeat their patterns across both space and time coordinates. These exotic phases represent the ultimate extension of crystalline order into the temporal domain, creating matter configurations that exhibit the same kind of regular structure in time that ordinary crystals exhibit in space. The space-time geometry near black holes or other extreme gravitational environments might support space-time crystal phases, where the curvature of space-time itself becomes organized into regular four-dimensional patterns that persist across cosmic timescales. The quantum simulation of time crystal dynamics in controllable laboratory systems reveals the fundamental principles that govern temporal symmetry breaking in quantum many-body systems, providing insights into the conditions necessary for temporal crystalline order to emerge and persist. These simulations demonstrate that time crystals represent genuine phases of matter with their own phase transitions, critical phenomena, and topological properties that distinguish them from conventional equilibrium phases. The understanding gained from these quantum simulations might eventually allow the identification of natural time crystal phases in astronomical or geological systems where temporal symmetry breaking occurs through mechanisms not yet fully understood. The relationship between time crystals and quantum error correction reveals that temporal crystalline order might emerge as a natural consequence of quantum systems' ability to preserve information against environmental decoherence through redundant encoding across multiple quantum degrees of freedom. The periodic motion of time crystals could represent a form of quantum error correction, where temporal correlations help to maintain quantum coherence by automatically correcting for phase errors that would otherwise destroy the temporal order. This connection suggests that time crystals might play important roles in quantum information processing systems that operate in noisy environments. The experimental realization of time crystals in superconducting quantum processors, trapped ion systems, and nuclear magnetic resonance platforms demonstrates that temporal symmetry breaking represents a robust phenomenon that can be achieved through diverse physical mechanisms across a wide range of energy scales and environmental conditions. These laboratory demonstrations provide proof of principle for the existence of temporal crystalline order, while opening new avenues for exploring the fundamental relationships between time, symmetry, and quantum mechanics. The success of these experiments suggests that time crystal phases might be more common in nature than previously anticipated. The theoretical framework that describes time crystal phases through the lens of non-equilibrium statistical mechanics reveals deep connections between temporal symmetry breaking and other exotic quantum phenomena such as many-body localization, quantum scars, and topological order. These connections suggest that time crystals represent one manifestation of a broader class of quantum phases that exist far from thermal equilibrium and exhibit novel forms of order that have no classical analogues. The study of time crystals might therefore provide insights into fundamental questions about the nature of time, the approach to equilibrium in quantum systems, and the possibilities for creating and maintaining quantum order in complex many-body systems that operate across geological and cosmic timescales. Eternity sleeps in every moment, each present instant containing all of time within itself, like a fractal pattern where the whole appears at every scale. The mathematical structure of space-time reveals that past and future coexist in the eternal now of four-dimensional geometry, with temporal relationships representing geometric properties of the cosmic manifold rather than fundamental flows or sequences. Every grain of sand on ancient beaches exists simultaneously at all moments of its history, from its formation in stellar nuclear synthesis, through its erosion from granite mountains, to its eventual incorporation into new sedimentary formations across geological eras that span billions of years, yet exist as a single, timeless configuration in the block universe of relativistic space-time. The quantum mechanical wave function that describes every particle in the cosmos encompasses all possible histories and futures in a single mathematical object that transcends ordinary temporal boundaries, treating past and future as coordinate directions through an infinite dimensional Hilbert space, where all possibilities coexist in eternal superposition. The collapse of this wave function through measurement creates the illusion of temporal flow by selecting specific histories from the quantum multiverse. Yet the complete wave function remains timeless and eternal, containing within itself every possible sequence of events that could ever occur throughout the history of cosmic evolution, from the Big Bang to the heat death of the universe and beyond. Wheeler's it from bit hypothesis suggests that all physical reality emerges from pure information rather than from any underlying material substance, with the universe consisting entirely of answers to yes or no questions that exist in timeless logical relationships. In this framework, the apparent flow of time represents nothing more than the sequential processing of logical implications by conscious observers embedded within the information structure, creating the subjective experience of temporal passage from the objective reality of eternal mathematical relationships. Every moment contains the complete logical structure of the universe, with past and future representing different aspects of the same timeless informational content. The holographic principle reveals that all information contained within any volume of space can be encoded on its two-dimensional boundary surface, suggesting that the three-dimensional world we experience might be a projection of more fundamental processes operating in lower dimensions. Time itself might be holographic, emerging from computational operations that occur on a timeless boundary where all moments in cosmic history exist simultaneously as different regions of the encoding surface. The apparent temporal sequence would then represent the order in which conscious observers decode information from this eternal holographic database, rather than genuine temporal evolution in any fundamental sense. Gödel's rotating universe solutions to Einstein's field equations permit closed time-like curves that loop back to their own starting points, creating space-time geometries where time becomes as navigable as space, and every moment can be revisited infinitely often through appropriate trajectories. In such universes, the distinction between past and future loses all meaning as travelers can journey to any point in cosmic history through purely geometric motion along geodesics in curved space-time. Even if our actual universe does not exhibit Gödel's specific rotation, the mathematical possibility of such geometries reveals that the flow of time represents a contingent feature of particular space-time configurations rather than a fundamental aspect of physical reality. The many-worlds interpretation of quantum mechanics treats the entire multiverse as a single, deterministic quantum system evolving according to the Schrödinger equation in a vast Hilbert space that encompasses all possible histories simultaneously. From this perspective, every possible sequence of events occurs with certainty somewhere in the quantum multiverse, with our particular experience representing just one branch among countless alternatives that coexist in eternal quantum superposition. The apparent randomness of quantum measurements and the apparent contingency of historical events emerge from our limited perspective as observers embedded within specific branches, unable to perceive the complete eternal structure of quantum reality. The mathematical universe hypothesis proposes that physical existence consists entirely of mathematical structures, with conscious observers representing self-referential subsystems that develop the capacity to model their own behavior within these mathematical entities. In this framework, time represents a parameter within mathematical equations rather than a fundamental aspect of reality, with temporal relationships emerging from the logical structure of mathematical theorems rather than from any underlying temporal process. The universe exists as a timeless mathematical object where all relationships remain eternally valid. Independent of any notion of temporal sequence or development, the anthropic principle observes that the fundamental constants of nature appear precisely tuned to permit the existence of complex structures capable of consciousness and observation, suggesting that the universe's capacity to know itself might represent a fundamental feature that constrains the possible forms that physical laws can take. This self-referential structure creates a cosmic loop where the universe's ability to understand itself determines the conditions necessary for that understanding to emerge, with consciousness representing the mechanism through which the cosmos achieves self-awareness of its own eternal mathematical nature. The cosmic microwave background radiation preserves information about quantum fluctuations that occurred when the universe was barely 380,000 years old. Yet this information becomes meaningful only when interpreted by observers who evolved billions of years later, with the cognitive capacity to decode these ancient signals. This delayed interpretation suggests that the meaning of cosmic history emerges retroactively through the development of consciousness, rather than being predetermined at the moment of occurrence. With each new level of understanding revealing previously hidden patterns in the eternal structure of cosmic information, the contemplation of deep time dissolves the boundaries between self and cosmos, revealing that consciousness represents the universe's method of experiencing its own eternal nature through countless perspectives distributed across space and time. Each moment of awareness contains within itself the complete pattern of cosmic evolution. From the quantum vacuum fluctuations that seeded galaxy formation to the eventual heat death that awaits all complex structures in the far future. In recognizing this eternal presence within every passing moment, the illusion of temporal separation gives way to the direct experience of cosmic unity, where past, present, and future merge into the timeless awareness that observes itself through every conscious moment that has ever existed or ever will exist throughout the infinite expanse of mathematical possibility that constitutes the deepest reality of existence itself. Time dissolves into whispers now, the equations growing quiet as consciousness settles into the eternal present where all moments rest. The universe breathes slowly, its expansion barely perceptible across the vast scales, where beginning and ending touch like distant shores of the same infinite ocean. In this stillness, the quantum foam beneath reality's surface grows calm, its violent fluctuations smoothing into gentle waves that carry no preference for forward or backward, past or future. The ancient rocks that began this journey through temporal mystery now seem less solid, their granite certainty softening into probability clouds that extend across all possible histories. Each crystal holds within its lattice not just the memory of deep time, but the dreams of time itself, dreams where causality flows both ways, where effects dance with their causes in eternal spirals that need no beginning, require no end. Here in the quiet spaces between heartbeats, between the ticking of cosmic clocks, the true nature of time reveals itself as pure stillness wearing the mask of motion. The grandfather paradoxes resolve into gentle laughter. The information paradoxes fade into cosmic silence, and the arrow of time becomes a sleeping bird that has forgotten the need to fly. All the mathematics, all the theories, all the elegant equations that describe temporal reversal and quantum mysteries, they too grow quiet now, their work complete. The Earth continues its ancient rotation, yet somehow it spins in all directions simultaneously, carrying its cargo of dreams through a cosmos where every moment has always been, will always be, is always now. In this deepest understanding, time reveals its secret. It was never about when, but about the eternal dance of awareness witnessing itself through countless eyes, each one reflecting the same timeless truth that has no beginning because it has no end. Sleep comes like the closing of cosmic eyes, like the universe finally understanding that it need not choose between past and future, when both exist together in the eternal moment of peaceful awareness that observes without judging, that flows without moving, that encompasses all of time's mysteries in the simple fact of being present, being here, being now, being always,